Today we will be performing the reaction of sodium hydroxide and nickel 2 chloride, which is a double displacement reaction. So to begin, I'm going to drag two 50 milliliter beakers down onto my workbench. We do not need an Erlenmeyer flask because there's no gas involved in this reaction. I'm going to drag 15 milliliters of our aqueous sodium hydroxide solution into one beaker and 6 milliliters of our aqueous nickel chloride into the other beaker. As we can see, the sodium hydroxide is a gray solution and the nickel 2 chloride is a green solution. Now if I pour the sodium hydroxide into the nickel 2 chloride, we can see that our double displacement reaction occurs. After the reaction occurs, we can see that there is an aqueous solution that is gray and a green precipitate at the bottom that has formed.
Now in front of you, you see the correct equation for this chemical reaction, and we have also calculated the molar amounts of both NaOH and NiCl2 that we added. Now the ratio for this, if there was no excess and no limiting reactants, would be 2:1 NaOH to the NiCl, because there's 2 moles of NaOH for every mole of NiCl2. However, based off the amounts we added, we have a 2.5:1 ratio. So NiCl2 aqueous is our limiting reagent, and we have an excess of NaOH aqueous, which means that in our ending solution, we not only have a precipitate of NiOH2 and an aqueous solution of NaCl, we also have some leftover aqueous NaOH solution left.
Thank you for listening.